Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, let us solve the next question. Question number 16, 2014 NEET physics paper. Students, let us solve the next question, which is number 16. Certain quantity of water cools from 70 degrees centigrade to 60 degrees centigrade. So the quantity of water which is cooling is from 70 to 60 in 5 minutes. So time taken is 5 minutes, and to 54, so from 60 to 54 in next 5 minutes. So this is 5 minutes. Okay, the temperature of the surrounding. What is the temperature of the surrounding? Suppose the temperature of the surrounding is theta naught. General notation. This is suppose theta 1. This is my theta 1. This is my theta 2. This is my theta 3. And this is the surrounding temperature. The temperature of the surrounding. So the question is to find this theta naught. So just we'll apply that Newton's law of cooling, which says that equation that I'm going to use here is that d theta upon dt, the rate of fall of temperature or the rate of cooling is equal to some negative constant, and theta minus theta naught. What is this theta? This is the average theta. This average theta we have to take, because from what temperature to what temperature, suppose from 70 to 60 is cooling, then the rate depends on the average of these two temperature. So this formula, if I apply it, is the temperature of the body actually. To make it practicable to this situation, I will write d theta is basically the difference of temperature, which is theta 1 minus theta 2. dt is the time for this change, which is 5 minutes. This is the average of the two, and theta naught is there. So I'll have basically the equations I'm just going to write here. Equation 1, theta 1 minus theta 2 divided by the time. Suppose this time is t1, this time is I call t2, by t1 is equal to negative of k, or only k you can write, no problem with that. Theta average is theta 1 plus theta 2 divided by 2 minus theta naught. This is one equation. Another equation will be from here. Second equation I'm getting is theta 2 minus theta 3 divided by t2. The time taken for that is negative k over theta 2 plus theta 3 by 2 minus theta naught. So I will just use those two equations and put these values over here and divide the two equations. Theta 1 minus theta 2, that's 70 minus 60, divided by time is 5, which is equal to minus k. Theta 1, this is 70 plus 60 divided by 2 minus theta naught. The other one is from 60 to 54 divided by 5 equals to minus k. 60 plus 54 by 2 minus theta naught. If I divide these two equations, this 5 will cancel out. From here it is 10, from here it is 6. This minus will cancel. This will become 130 by 2 is 65. Okay, so 65 minus theta naught. This would be 65 minus theta naught divided by, this is 57, or yes, 57, because 54 plus 6 here, plus 6 is 3 plus 3, so 57. I'll write here 57 minus theta naught. This number can also be written as 5 divided by 3. 2 5s are 10, 2 3s are 6. If I cross multiply, this will become 5 times 57 minus 5 theta naught equals to 3 times 65 minus 3 theta naught. This goes to that side. Theta I will keep one side, taken to this side, and this goes to that side. And theta goes to that side, it becomes 5 theta minus 3 theta is 2 theta. 2 theta naught. This goes to the other side, so this becomes 5 into 57 minus 3 into 65. If I solve these two equations, this I will get the value of theta naught. So 2 theta naught is 5 times 57. If it is, so I'll write that 57 5. 285, and 3 times 65, 195. So if I subtract that, it is 185 minus 95, so it is 90 around. If I add 90, then it is like that, so it's 90. So 2 theta naught is 90, so theta naught is 45 degree centigrade. So if I see the option, the temperature of the surrounding is, then the temperature of the surrounding is 45 degree centigrade. This is option number 1, which is correct, 45 degree centigrade. So this is the right answer to this question. Okay, thank you.